Hello, my name is Mark and I'm the founder and Chief Technology Officer of Asteria Technologies. Today we are going to demonstrate you the coefficient of performance bigger than 1 operating mode of Ahimsa electric generator, which lab prototype we have right here. We are going to peek in what's in this mysterious box, and then we are conducting two tests with it. During the first test, we are measuring the operating voltage of the generator, and during the second test, we are adding an electrical load to the generator and see what the readings are then. During our second test, we also, during both of the tests, we have also all input energy measured, which we use grid energy for the reason of simplicity. As of now, we are having voltage reading, which is true reading, effective reading. Root mean square, which means that this number doesn't need to be further translation or interpretation. And then we also have a true current reading, which is meter number 3. And then we have ambient noise level, which is also useful with our test. And input total energy, which also takes into consideration that we are powering some of our power supplies and a couple of internal computers, which are also in use when we use our automatics. So let's begin what we have in this mysterious box. This is the first time ever in history that we are showing anybody what's inside here. For obvious reasons, we cannot show you the middle section right here, because it contains too many of our trade secrets and technical secrets. But basically it contains wiring and conjunctions and exact techniques and components that we are using, which we don't want to disclose. But the most important part is here, this black piece of art, which is our charge generator, and which is the heart of the whole system. It's electrically driven by our industrial automatic system. And that's why we have also this larger power supply here. Then we have two smaller power supplies for computers. And then we have some special made electronics prototypes and our power collector, which we use as an intermediary buffer to store energy. And later we're going to build also frequencies with it. And then we have a main switch. I turn on the main switch, and we are closing the hatch. And the upper section, we have several inverters here for output power for later testing, that we can test how several power converters work with our technology. So we're closing the hatch now. And before we are going to test, I also go quickly through that we have a meter number 1 here, which measures internal input, not internal but input power. It has all the ready to go systems, ready to go power consumption here, and now it's ready to go. We have ready to go reading of 15.3.6, a little bit fluctuating, the wattage. Then we have charge generator voltage. We are switching this to AC mode. And then we have a meter 3, which measures current in the system, also AC mode, and these are all category 3 class meters. Then we have our ambient sound level. We have roughly 44 decibels of sound level as of now, before beginning the test. And then we are also measuring time during the testing. But before we are starting the first test, I'd like to introduce Ailika. Please, Ailika, come and show yourself also to our audience. Ailika is a very important partner in the project, and she's taking care of the administrative matters, and she's also the person who will take care of the work packages shipments and sees that everything will be sent out with the utmost care from us. So Ailika, would you please, at the moment when we have reached our target test speed, take a couple of pictures here with your phone, and then we are going to show those pictures also in detail for you when we are showing the video. So now you got took the 0 level pictures, and now I'm going to accelerate the system. Yeah, we have no load. Accelerate the system to the target speed. Sorry. And starting the test now. Take the pictures, please. Go on. And then we will also read out loud the readings. We have input power meter 1, 83 watts. We have meter number 2 voltage, 57.75. And we have current 0.005. Ambient noise 74-75 decibels roughly. So coming down now. Well, we have a little bit less than 1.5 minute test duration. Okay, this was our first test, and now we have 57, 83, and 74 decibels, if I'm not mistaken. Well, now I'm going to add our electrical load. I just added load, connected to plug one wire, and we are going to repeat the test. And now with the electrical load and all the I'd like to say that all the energy that we are extracting from the coil, and we are working at the moment with the test configuration. We are working with one coil only out of multiple potential coils that we could put in. We are working with one single coil only, and we are taking the energy out to our collector, intermediate collector, and then we are targeting the same energy back to the generator in order to show you the effects of what it causes. Okay, and Ailike, could you please at our target speed come and take a couple of pictures again? And at the moment, starting the test now. Please take the way we have target speed. And we have, I read out loud the readings. We have total input power, meter number 1, 387 watts. We have voltage true, effective 318 volts. We have 7.4 amperes. And we have 77-78 decibels of ambient noise coming down now. So, as you just witnessed, we had quite a different readings when we compared test number 1 and test number 2. So, I would like to first bring out that during the first test we had internal operating voltage 57, and during the second test we had 319 volts of effective voltage. Then we had also measured 7.4 amperes of current fluctuating in the system, and we had 4, 3, 4, even 5 in some cases decibels more noise. So when we are multiplying 319 to 7.4, we have wattage, total output wattage, we have 2360 roughly. Then we had when we divide this with input energy 388, we have a coefficient of performance during the second test 608. So, ladies and gentlemen, we were just witnessing the coefficient of performance operating mode at the level 6.1, which is pretty good. But let us reason a little bit of why we are having those different readings, and why did the main primary reading is the voltage. The voltage is that why didn't the voltage drop, which it usually does when we are operating all electric generators, regular generators out there. When we are adding the load, voltage should drop. But in our case, it raised almost like 6 times. So why was the voltage higher with the second test than it was with the first test? And the reason is very simple, because we were not using inside the generator only the principles of power engineering, but we were adding also in our design some principles of radio technology and circuitry, which is operating or targeted to operate at a certain frequency. So we have tuned this internal frequency into the level that it best matches our load. So to speak, our load and generator coil are in very good harmony towards with respect to each other. This is one reason. But another reason is that we are working with our generator with two ends actually. And first, the input end. It's very important that I now take a little theoretical example with the coils. This is by the way not a coil from this prototype type, but this coil is from one of our earlier prototypes. But very good to show the effect, some of the effects here. So when we are inducing the electrical charge and potential inside the wire, we have to influence the wire with a change of the magnetic field. Not just the magnetic field, but a change of magnetic field is very important. And the late scientist Dr. Thomas Purdon in his public work very clearly distinguish and also refers to earlier scientists such as James Clerk Maxwell and also Whittaker, that who discovered already 100 years ago that there are at least two components in the electric current. The first component, which is widely taught at the schools, which we all know, is actually, it's not the first, it's the second. It's the effective, no, not effective, but the resulting component is the electron current. So the charged particles are traveling first towards the outer surface of the wires and then alongside the wire. And it is true that some of the electrical power is the movement of charged particles and electrons in our case. But what triggers actually, what those scientists say, is that the first which appears in the system is voltage potential. And we need to have a higher voltage because voltage itself holds a doorway to access to the energy actually. The higher the operating voltage, internal operating voltage, the more energy can be extracted with this system. And also a higher frequency plays also a lot of role, because frequency is the time or the times in our so-called measured time period where we are extracting this energy with those coils as a pockets, so to speak, very generally. But what happens here during the process of while we are generating electricity and inducing those charges is that first voltage potential appears, and second electrons start to move. And in a regular generator, when we are connecting our load in a fixed manner to the terminals of the generator coil, and we notice that the bigger the electrical load, the harder it is to spin the generator, because this electric energy which is being induced here is being directed through the load back to the generator. And basically it's a closed circuit we are where the energy is blocking its own way, so to say, and makes this generator too hard to work harder and to turn harder, which is more energy consumptive, and which is why it's harder to turn the generator or spin the generator while we are extracting large loads here. So as we witnessed in our second test, we were extracting almost 2.4 kilowatts out from the generator and directed this energy back in. But the meter number 1, which showed us the input wattage, didn't show 2.4 kilowatts, but showed only less than 400 watts. And that's including all the housekeeping costs, so to say, all the support electronics, which also consume a little bit. And also our electric motor, which is precision controlled, also takes some amount of energy, as we witnessed. The whole system with a no electrical load took also roughly 80 watts, and the excess of 300 watts that we had, the difference between the two tests with our meter number 1 input energy is basically the 300 watt it caused the extra friction back to the system. And so when we now go into the some of the principles that we have used during the design of our generator, is the fact that when we want to extract as much energy as possible, we first have to see that the voltage is as high as possible, reasonably possible. And second, the frequency is high as reasonable possible. But another thing is that when we the system or the starter and rotor should be designed in a way that from one hand all the coils can take the maximum advantage of the passing magnetic field, but at the same time they should influence the rotor back at the very least, the very minimum amount of energy possible. And as we saw, we were also having here quite a good effect on that. But from an output point of view, we have to work to gain higher frequency, high voltage. And in order to do that, we should or consider to combine two different disciplines. One is power engineering and another is radio technology, which are principally what we have been doing here and continue to do. So, but Bertrand in his literature also tells very many good aspects about effective electrical systems. A lot of the things he doesn't say directly, which means that you have to also go deeply inside the effect. And it's also, now when we know that there are two components in the electrical current, we have to when we want to have our system work the most efficiently, we have to figure out a way how to extract the largest proportion there is possible to the buffer collector of the massless current. And the current with mass, the current with electrons, we are going to collect some of this as well. There's no doubt about it as well. But the bigger the proportion of the massless current, it's also called in some literature called as a massless displacement current, the better the coefficient of performance of the system. And another aspect is that when we now observe from a very fundamental level of what's going on when we are inducing the charge inside the wire, is that when we are not affecting the wire, then it's so-called in its natural equilibrium state, so there's no potential in here. But when we are now affecting it with additional outside magnetic field, change of the magnetic field to be more precise, then this field change disturbs this natural equilibrium state which is the interaction between all matter that we have actually in the universe, which is in continuous interaction with the quantum vacuum, as we call it, of time space. And this time space is omnipresent. So it has always been there, it is there, it will always be there. So the extraction of energy, electrical energy, is actually more to do with the subatomic physics than it has to do with physics in the level of material aspects of the matter. So, this is the effect that we are using, and if you are interested to have this technology also to benefit you and your dreams, then please take a look at the Indiegogo Indiegogo website and look for Ahimsa generator project. And please back Ahimsa generator project, because our early backers can have the most benefit out of the project, because they have the secured order position, which is valid for 10 years, which they can either use for the first model which comes out, or any of the next models during the period of their sponsorship validity. And also they have significant discounts. And the sponsorship packages are also transferable if you want to give them to somebody else at a later stage. So thank you for watching, and hope to see you soon. Thank you.